We'll just pretend it's like lightning.
Just flicking. Put a little thunder with it and then.
Right.
Be easier.
Looks like God has endorsed.
All right, can you hear
You're
me
even
okay?
a pie or cow and you missed it. Way to go, people.
Can you hear me? I did. No? Shoot. Try again? Can you hear me now? Awesome.
The wife has health issues.
They have health issues, for sure.
And the little son has health issues.
But like general family.
I think we probably can.
In the whole state of California,
I know.
I guess it doesn't matter what the table
Yay!
says. I don't know if there's any other place.
Okay.
All right.
Oh, thank you, sit on that side of the room.
Right?
I bet you would have learned more from my history class.
I learned quite a lot.
I really hope Bob shows up.
I know, because it's not looking good.
Is he in a meeting? Can we
I don't know.
text him?
I'm gonna text him real quick.
Yeah.
I know it's-
Everybody can hear us now talk about Bob not showing up.
Oh,
This is it's being streamed. How about Bob?
Of course.
Everyone's watching you text them.
Hey, I would love it. I would
Well, I'll
love
tell
it.
you what, if Bob doesn't come, then the only House supporter in the room is because of the representative. So, Frank,
that would be great. That was cool. No, all you have to do is attack pie.
That's that. Yeah, seriously, you don't have to respond to any questions.
You have
They
to-
can ask you questions like, well, what I really want to talk about is how much money from topology you got. You know?
It must be nice having no record to run on.
He's done nothing. He's been around forever. He's done nothing. Nothing but cause trouble. Break students' minds. Nothing has come out.
It's been 47
You should
years.
see this guy's SRIs. Holy crap.
It's not funny.
You
That's
can't
not funny.
trust anything this guy says. What's great is that we're broadcasting in this room, so everybody can hear everything we're saying right now.
That's right.
Of course, I don't know how many people, actually, how many streamers do we have? Do we have?
We have 10 streamers watching,
Wow.
and one person says they can't hear anything.
Oh.
So I'm gonna go out and do another sound check.
Take off your face mask.
Here, let me see if they,
Apparently, it's muffling your voice.
can you hear something now? Well, that's funny, it's my mother-in-law. Mom, try to turn your speakers on.
The only person that shows up to the debate.
Is there an 8-year-old in the room? Get him in the computer.
I love you, Mom. Except that she can't hear me, so I don't know if it works.
Shoot.
We've officially got more people watching online than we have in person.
That's what we're hoping for.
Well, I guess Ray
Oh.
told his class.
She can hear you.
No disrespect.
I'm glad.
to you, of course.
In Nebraska.
Oh, he did?
So that's what, he's gonna be joining his class with his husband.
Oh, good.
You can't beat
That is
that.
wonderful.
Nice to have some.
Right? Okay, Ethan, you just about ready?
Are we ready to start? Oh,
Do you have the, is that your phone that's doing the Buzz Lightyear thing?
Yeah, it's my
Broadcast live.
Have you guys, I know you probably.
have you guys been getting Amber Alert sounds on
You
your
think of
phone?
calling Bob?
I emailed, I texted him. Let's see, that's probably what I just got.
We're live, aren't we?
Yes, I said 1 minute.
Okay.
We are live.
Yeah, I can see.
1 minute at what speed though?
So what I get is that podium, and I don't get that at all. And
Oh. He had an important thing, he had an important call he had to take.
Okay, who's in the Delta?
I can't tell you what the call was about, but it was legitimate.
Oh, Alan, can't
What?
hang that out there like that.
Was it the dean?
Something to do with his job. I don't want to say that.
See, this one?
It gets worse every time he says
It was
it.
something, he was
Yeah, that just debates.
fulfilling his duties as chair.
Oh, okay, got it, got it.
I don't think it's gonna be more control or polite. They've never seen those two.
Yeah, he's gonna come. We'll actually have you sing in
Maybe
just
they
a second.
reined it in.
Okay. Wow, we've got a lot of, there's a lot of
Well, that's
commentary.
for
This is great.
drawing straight lines.
Alan?
Yeah.
It's the straight edge I need.
Greg.
Oh, fun.
Apparently, it's sort of like he shared with some of the grad students in Nebraska.
The chat?
Yeah, whatever is.
Oh, that's a good idea. I'm not 100% certain if I can. Let me see if I can do that.
Oh, yeah, good.
Yeah, that should work.
We close out the, okay, now we've got.
So you guys can see the
You
screen.
close out the
We've
chat,
got both
okay,
podia
or
there.
do we want the chat?
Well, that's why they wanted it, is they wanted to see the chat, right? Right, Yvonne John? Okay. I apologize for the delay. We will start just momentarily. Ethan, I think we'll go ahead and have you sing first. Let me find the right thing.
Do we stand for this?
I'm gonna have you stand right here, buddy, okay? And I'll give you a microphone in just a second.
Yeah.
The map. Okay, are we ready?
In a sec, we'll do Ethan's thing first, to start us off. I hope this isn't like too loud.
We got volume control right there.
You ready, Ethan? Okay.
All right, good.
All right, welcome to the Pi versus Tau debate. I'll let the moderators introduce the debaters in just a moment. But first, we have a little presentation where my son Ethan Parry will sing the Pi song by Brian Oden, also known as Song Drops.
They said, would you like some pie? I said, yes, I would. I forgot and I didn't know. I wouldn't do it if I could. They said, we're not going to work out. 2, 6, 7, 5, 1, to my 3, 2, 66, 4, 3, 3. They said, would you like some pie? I said, yes, I would. I forgot and I didn't know. I wouldn't do it if I could. They said, we're not going to work out. 2, 6, 7, 5, 1, to my 3, 2, 3, 4, 6, 6, 4, 3, 3. They said, would you like a pie? I said, yes, I would. I forgot to do it. I wouldn't do it if I could. They said, we're not going to work out. 2, 6, 7, 5, 1, 7, 9, 3, 2, 3, 6, 6, 4, 3, 3. Oh, these are
Give it up for him, everybody. Thank you. All right, do you want to use your microphone or mine?
I'll just use this one.
You're good.
Good afternoon. From an undisclosed location on the Utah Valley campus of Utah Valley University, we welcome you to the first and only Pi versus Tau debate of this electoral year. Our audience has been pre-selected to be heavily biased toward the constant of their choice and our social distance under COVID-19 regulations. They have all agreed implicitly by their attendance that there shall be no external noises or disruptions, except for right now, as we welcome the candidates, Dr. Bob Palais representing Tau, and Dr. Alan Parry representing Pi.
Well, everyone. So that's your podium there.
I'm joined here by my co-anchor and co-moderator, Dr. Joe Simons, and Joe will start us off with the first round of questioning.
All right, candidates.
Do presentations?
Oh, it's.
See
I don't
already.
have it set up to do that. We were just
Mr.
talking.
Chairman,
Okay.
Mr. Chairman.
Yep.
Okay, can we follow the rules? I viewed the 2016 debate. It was very unruly. So can we have both candidates here at the beginning of the debate agree to follow decorum?
Can you define decorum, please?
Well, for instance, there was a lot of talking by the other candidates.
I'm sorry, could you say that again?
Decorum is what we say it is.
Oh, okay.
Each candidate will have can make a 2-minute opening statement. I will tell you when the time starts and when it ends. Dr. Parry, Dr. Palais shall go first.
Oh, I was just pointing out that we have a whiteboard in case,
Oh,
just
okay.
so they know.
Well, Dr. Parry, we'll let you go first, and your time begins right now.
You can stay there, Rob.
Can I see if I can
Sure.
connect to HDMI also while you're doing that?
Sure.
Cool.
I don't know, I don't know if they'll be able to see it on the live stream though.
If it's on the screen possibly?
I think it's just sharing the camera.
I think. But does the
I-
camera see that?
No, it's only set to see this region right
Oh, I
here.
see, okay.
Sorry, I hadn't really planned on having,
Yeah, last time we
presentations,
had
yeah.
this presentation, so.
yeah. Sorry, I guess we should have communicated better.
Okay.
That was my secret plan. Anyway.
Okay, your time begins
Oh, come on! I
now.
thought you were going to say my time to stop.
No, your time begins now because of technical difficulties.
The controversy over which circle constant, pi or tau, is superior is an old one. Even Leonard Euler seemed to change his mind from one topic to the next and used whichever of these two constants was the most convenient for the topic he was discussing. However, if we are to pick one of these values over the other as a standard, then we must really ask which of the two constants is more fundamental mathematically. That is, how frequently do these constants appear in mathematics, and when they do, are they appearing because of something mathematical or something notational? My opponent and other popular tau enthusiasts, such as Vi Hart and Michael Hartle, would lead you to believe that tau appears fundamentally more often than pi. But this is because they are very selective of the motivating examples they suggest for tau. They use a very small set of examples that support tau and ignore the examples where pi represents the mathematics better. Now, it is true that there are parts of mathematics for which tau appears fundamentally and would make for a better choice in that case. But when taking a wide and inclusive view of all mathematics, it is very clear that pi occurs much more frequently and almost always more fundamentally than tau. Pi even does this for the topics that tau enthusiasts often cite if they zoom out from that specific example even just a little. These topics include areas, angle measures, polygons, curvature, the 4 trig functions besides sine and cosine, Euler's formula, the normal distribution, and the Fourier transform. Using pi would be far more inclusive of the naturalness of how we represent each of these topics than tau would be. In fact, if we look at how tau affects the presentation of mathematics in a general sense, in almost every topic, replacing tau with pi would dramatically increase the number of fractions throughout. This only shows that integer multiples of pi are far more common in mathematical, this not only shows that integer multiples of pi are far more common in mathematical formulae, but indicates that mathematics instruction would be significantly harder on the whole with tau
Your
instead of
time is
pi.
up.
creating an even wider divide between teacher and student.
Professor
Pi is the
Parry,
great
your
unifier
time
of these
is
groups,
up.
while tau constantly tries to divide us into fractions. It is my hope that the fundamentality of
Professor
pi will be
Parry,
revealed through the course
Your
of this
time
debate.
is up. Thank you.
Dr. Palais, your 2 minutes.
All right, I actually dispute the simplification, that's the main reason. I wonder if you can actually, no, we probably can't see this if I don't do this, but for the audience, they can zoom in off. Make math friendlier. Make math friendlier with tau equals 2 pi. And I just want to begin with some endorsements. I want to thank the moderators, Dr. Parry, Dr. Andrus, from the original, setting up the original debate with the Count and others. Too bad the camera can't see all this. Endorsements from Scientific American. Let's use tau, it's easier than pi, the tau of tau. From MIT, does their admissions Pi Day but added at tau time. The key lime tau beer. People can see these on the site. Mathematician John Conway of the Game of Life, who said in Physics World 2008, I asked him which, and he says 2 pi is obviously the correct constant, 6.28. The Theorem of the Day site, and has many endorsements. The Khan Academy, plus.org, plus.maths.org, and Numberphile. Several others. The XKCD, and other cartoons. You can see all of these. The American Mathematical Society in their publications. Annoying Precision. The University of Utah, Ethan Brown of Tau 2000, and students in
Dr. Palais, your time is up.
Students in Vivian Farrow's class. So,
Dr. Palais, your time is up.
okay,
Can you switch it back to the,
yes.
so they can see the chat?
All right, let's begin with a question of fundamentals. This question goes first to Dr. Palais. Tau has a natural alliteration with turn. So 1 turn of a circle is equal to tau radians. Why is this definition more intuitive as the fundamental constant?
Absolutely. The motivating principle of tau was the fact that students in calculus or trigonometry are deterred by the ugliness of pi because it makes a quarter turn that every student knows 15 minutes is a quarter of an hour. This is a quadrant, it's right there in the name, and so that should be a quarter turn. When we say, I've made a quarter turn, a half turn, 3/4 turn, that's natural with turns and tau. So that's one of the reasons it was used for tau. People said tau is used for other things, but pi is used for the prime counting function. Pi is used for projections. Pi is used for permutations. Pi is a mess because it shows up in all kinds of things other than the half circle constant. And why do you want to say a half circle constant? One of the endorsements later is by Hertz, not Avis. Avis goes with pi, but Hertz is frequency, and it's in units of 2 pi, just as it says on Wikipedia. If you see Hertz, if you go to Hertz frequency, the conversion factor is 6.28. So Hertz for pi, Avis for, Hertz for tau, Avis for pi. It's fundamental, it's a measure of rotation, and tell me, is this a quarter? Did I just rotate a quarter or a half? Seems a quarter to me. Great question.
Thank you. Alternatively, to Dr. Parry, your response, and also pi has a natural alliteration with the word perimeter. Why is your measure, or why is your constant a better fundamental constant for the circle?
So, first off, let me respond to my opponent because he keeps talking about turning all the way around, as being a full turn. But If you were to ask somebody, when you were calling them down the hallway to turn around, they would make one full turn to look at you, okay? In fact, I think you would find that perhaps the
Remind the
reason,
audience to please keep the noise down.
I think you would find that perhaps the reason why my opponent here must cite so many people who endorse him is because there isn't much logical reasoning to explain why tau is better. Because, and this is my point from before, he only looks at one part of what's going on with the circle. He only talks about rotation. For example, if we used area instead, you suddenly have something completely different. If you look at the area of the unit circle, it is equal to pi, or tau halves. I don't know about you, but that does not look like a half to me. It looks like a whole, an entire pi, if you will. If you have half of it, the area of that region is pi halves, while with tau, it is tau fourths. I've never been to a Thanksgiving party where I asked for a fourth of a pi and got that. One quadrant here, the area is pi fourths, or tau eighths. So you can choose whether or not you want to talk about area or you want to talk about turning. Now, the issue is this. Both of these occur, and I will admit that in turning, the tau does make a little bit more sense, but the tau is an integer multiple of pi. And since pi works in this case as well, and avoids the fractions and the divisiveness here, it makes sense to keep things with the simplest number that comes out in fundamentality. Since pi comes out fundamentally in this location and doubles to something that's fundamental in rotations, it would be better to use integer multiples than fractions, because I don't think anybody in this room, any math student or anybody who's streaming would agree that their mathematical instruction would be better with more fractions than less.
Thank you,
Can I
Dr. Perry.
rebut?
You have 30 seconds for rebuttal.
30 seconds to rebut.
I don't know if you can see, unrolling a circle into a triangle whose base is the radius and whose circumference, perimeter, is the altitude. And so if you take this circle and you unroll it, you get a nice triangle with 1/2 radius times tau times radius and the area of a circle, which you can see in a nice animation, if I was projecting, of a, let's run it.
Thank you,
again.
Mr. Chairman.
There.
Thank you, Mr.
Can I
Chairman.
rebut that too?
10 seconds, we need to move on.
Look at the equation of an ellipse's area. The area
What's
is
ellipses?
pi AD. It has a pi in it, not a tau.
Thank you, Dr. Perry. This question is directed to both of you. Well, we will have Dr. Palais respond first. The 19th century mathematician Leopold Kronecker famously said, "God made the integers, all else is the work of man." So how would each of you convince our German friend that your constant is the superior work of man? We'll start with Bob.
For those who can see the screen, there's unrolling the circle into the triangle with 1/2 tau r squared, which is why that's very natural. So Kronecker, why is, again, the Kronecker quote?
The Kronecker quote, "God made the integers, all else is the work of man."
God made whole terms. 12 hours is a whole term. If I says, can you turn half a turn? This is half a turn when you're doing rotations. So why do, the main origin of this is to make math friendlier. This is the title of my presentation, make math friendlier and more inviting, because people say 360 degrees, 2 pi is more natural, and it's like, and so that 90 degrees is unnatural, but we can change it to pi over 2 in a quarter of an hour. I challenge you to ask Mr. Kronecker, a very good man. He's a very, very good man. He's
He
done a
couldn't be
lot.
here today. Okay.
He's done a lot for mathematics, but ask him if, if he asks any college-educated,
So we can see the video.
yes, if,
Just switch it back to the PC. It should be able to-
or they want to say this,
Sorry, I switched it back. Yeah.
so I'd say ask most college-educated people, what's 90 degrees in radians? And they say, I don't remember. Ask a fifth grader what's 15 minutes in hours. They'll say it's a quarter of an hour. That's the problem with pi.
Thank
That
you,
it's
Bob.
turned something natural into something unnatural,
Thank you, Bob.
unfriendly. He's unfriendly.
Alan, would you like to respond?
I would love to respond. Let's talk about friendliness here. I'm gonna show you, switch back to the PC there. I'm gonna show you exactly how friendly mathematics would be in trigonometry and geometry if you use tau instead. Let's take a look at some formulas you have to memorize. So let's talk about the circumference of a circle, 2 pi r with pi. It is pi times the diameter. It's also tau radians, so let's make a little division here, or tau over 2 diameters. Let's take a look at the area formula. So far, not a lot of difference there, but pi r squared for the area. I'll admit, pi is not so great with the diameter on there, but take a look at what tau looks like. Let's take a look at surface areas of spheres. Look at how close those two formulas are when you use pi, circumference versus the surface area of a sphere. 2 tau r squared, tau over 2 d squared. Now let's take a look at volume. We have 4/3 pi r cubed or pi d cubed over 6. Over here we have 2/3 tau r cubed and tau d cubed over 12. If you just look at how many fractions you get when you use tau, there are twice as many fractions there as there are if you use pi. Let's take a look at some trigonometry now, okay? Because they talk all the time about sine and cosine, but they completely ignore the other trig functions and how much worse they get if you use tau. So let's take a look at sine. Let's take a look at sine of x, cosine of x, tangent of x, cosecant of x.
We'll give you a chance to rebut.
We've got,
What's the period of sine and cosine?
let's take a look at the periods, okay? Let's look at the periods in terms of pi. Now, I agree, you get a 2 pi here for sine, you get a 2 pi here for cosine, you get
Yes.
a tau and a tau, but take a look at what happens with cotangent, cosecant, and secant, okay?
30
You get
seconds
a
out.
tau halves.
Use them every day.
Sorry, you get a pi here and a tau halves, and a pi here and a tau halves. You get, down here, you get 2 pi's and a tau, and 2 pi's and a tau. If you look at the zeros, it's even worse. If you look at the zeros of these different functions, or where their asymptotes are, or what their domains are, the number of fractions you get under tau almost doubles when you use that. It is only better in the sine and cosine case.
Yes.
For these other ones, it's not better than not better.
I
So
grant
you end up getting way more fractions. So we want to talk about
Thank you, Alan.
make mathematics kind.
I
Think of
grant,
how many fractions your students would have to learn.
I grant my esteemed opponent this point, and I wish to ask him, relatively, how often in mathematics are sine and cosine, the horizontal and vertical factors in polar coordinates and spherical coordinates, everything else used relative to cotangent, cosecant? Would you say maybe 95%?
Since you asked me a question, can I respond?
You can.
Okay, so you're right. Yes, sine and
No,
cosine does show
that's
up.
enough, that's enough.
Sine and cosine shows
That's
up a little bit
enough,
more.
right,
But the
right.
problem is, so do the other things. And sine and cosine are already beautiful with pi. They're not that bad. They're certainly not as bad as the other ones do with tau.
They're
So
horrible.
the issue that
They're
you get,
horrible.
the issue that you get is that for tiny little aesthetic improvements on sine and cosine, you give up so much. And it's not just about trigonometry. It's literally everywhere else in mathematics. It gets worse when you use tau.
No, it always gets better, which is why Leonard Euler, the other
I've got 10
Leonard,
pages here to show you why
Thank
it's
you,
worse.
gentlemen, we'll have to leave this topic.
not Leonard Kronecker, Leopold Kronecker, but Leonard
Again,
Euler.
you keep having to appeal to authority, which doesn't hold any sway in a logical argument. If you actually had a logical argument, sir, you should present it.
Thank you. Dr. Parry, you brought up the topic of beauty. One of the most beautiful equations revered in mathematics is that of e to the I pi plus 1 equals 0. Euler's identity, which combines the natural base, the imaginary constant, the circle constant, the multiplicative identity, and the additive identity. Why is this a more natural, in light of this, why is pi the more natural fundamental constant for the circle than tau?
I'm glad you brought this up, and I seriously doubt I need 2 minutes to answer this question.
You don't have 2 minutes to answer.
Well, that's good then.
See, flies go to fly.
Let's take a
Fly
look.
on his head.
I have no idea what you're talking about. Let's take a look here.
The flies are attracted to pi.
So here's Euler's equation with pi in it, right? Now, tau would try to argue that perhaps this is a better one, but take a look at what happens if you add this over here. You not only get I and pi and e, the multiplicative identity and the additive identity. You don't get that if you try to get 0 on one
Multiply
side
and
here.
divide by the golden
Now-
ratio, it'll be even better.
Let's talk about where this formula comes from. This comes from cosine of theta plus I sine theta. When you're talking about fundamentals, the lowest, the smallest positive number of theta for which this here produces a real number is pi, not tau. Tau is the second time it produces a real number. Whenever in mathematics is the second time that something occurs, the fundamental moment that it occurred.
Exactly. The first time it gets back to where it started.
The first time it occurs is what's fundamental. So the first time that this occurs, first positive number, first positive theta that makes this real, this real is pi. And in fact, every real solution of this equation here, everything that produces a real number is a multiple of that first one. If you use tau, half the time it's a fractional multiple of it. That does not seem fundamental to me.
Thank you, Alan.
Dr. Palais, your response.
The first time it returns to its initial conditions. That's the whole.
Still the second time is real.
The purpose of this equation is the fact that dz dt equals I z. What does that really mean? That just means that if you write it out in real and imaginary components, multiplication by I is a quarter turn rotation. This is essential. So here's the displacement of a point going around the unit circle. I have this in a video that if I could show this, but here's the displacement, here's the velocity, which is the quarter turn. That's the definition of sine and cosine, because it says if you know that this is AB, then the vector for this is minus BA. Just says the velocity of the displacement, cosine sine, is a quarter turn, nice in terms of tau, minus BA, which says the derivative of cosine is negative sine, the derivative of sine is cosine. It's right there in the picture, very natural when you think of it in terms of that. So therefore you get starting at 1, and then tau is how long it takes to get back.
Chairman. Thank you, Mr. Chairman.
Yep.
Very good.
Can I be called Dr. Associate Chairman, please?
Yes, we can accommodate that.
Thank you.
Vice Chair.
Just a little fairness, please.
All right, gentlemen. Which is larger, tau to the pi or pi to the tau?
Well, clearly it's pi to tau, which fundamentally shows why pi is the base of all mathematics.
you like to dispute that claim, Dr. Palais?
I would just like to bring in another endorsement. I wish you could see that.
Again, he's going with endorsements because he has no logical argument to dispute.
Yep, Chad endorses Tau, the Chad Hartle Pi.
I wonder how much they care about your students learning, Bob. They don't have to answer S or I's
Do
or
you
get
notice?
tests.
Do you notice the resemblance on the right and
Not
on
really.
the left?
Not really.
And notice, when we were talking about other applications, this is a quarter turn of a unit circle is pi over 2 because what? Is overhyped is only half as good for solids of revolution. Integrate 2 pi or integrate tau. That's a great one, I think. Anyway.
Thank you, Dr. Palais. Thank you, Mr. Chairman. Let's move from some mathematical ideas to some more practical ideas relating these principles. To begin with, and this question will go first to you, Dr. Parry. Pi Day is celebrated in math departments around the country in universities and high schools during March, the middle of March every year for those schools that don't have a spring break. Tau Day, incidentally, falls in the middle of the summer. For publicity reasons, why is pi the better fundamental constant?
Well, I mean, I think you clearly can see right there that given the fact that Tau decided to have its day on when kids are out of school, it shows how unfriendly it is to kids learning. But I think the other thing that's important about Pi Day is that it also happens to be Albert Einstein's birthday. So on Pi Day, you also happen to get this nice convergence between physics and mathematics. And honestly, if there was any sign that God voted for pi, it was the fact that he gave us our greatest physicist on the day of pi. So I'm just saying, I don't know. It sounds like pi really is a lot more kind to students and would like to help them out.
I would remind you that religious arguments belong at the other Utah County University.
Well, I've got more religious arguments. Can we do that?
No. Dr. Palais, your response. How can Tau work for publicity when most students aren't in school on Tau Day?
Exactly, because they aren't in school on Tau Day, because it brings them back to math and they enjoy it. It's in the height of the summer. They can eat lots more they can eat 2 pies because they're getting exercise in the summer rather than sitting in the end of winter. The skiers are sad because the skiing is gone, but the hikers are sad because they can't go hiking yet. Pi Day is just the worst day of the year, in fact. Tau Day is the best day of the year.
I'm sure that's exactly what all those kids out there want to hear, is that they get to do more math during summer vacation.
Notice in the Pi is Wrong original article, Stirling's formula is better, Cauchy's integral formula.
We can talk about formulas. If he's going to shift the topic, can I talk about a few formulas?
We have a lot of questions to get to tonight, so we'll need to return to those.
Follow the rules, Bob.
Follow the flies.
All
I
right.
have no idea what you're talking about.
Bob, this is a question for you. Where does it stop? Okay. Tau replaces pi. Well, base 10, there's better bases to count in than 10. Is E the best number that we've chosen? Could you address those concerns?
Those were really nicely addressed in that article where Conway was quoted in Physics World called Shifty Constants and Constant Failure. Are we using the best constants in various things? And so no, this should go on because the use of the word limit is just as terrible as the use of pi. In fact, there's not a single use in the English language of limit that means constraint. We talk about, in English, it's the credit limit, the speed limit you always go above, your ticket limit. But in calculus, it's what you want to approach, unless it's the limits of integration, which is the right use of limit. So that's another example. So there are lots of ways it can go productively and helpfully to make math more friendly. In fact, we always trip students up on the x-intercept and the y-intercept. The x-axis is y equals 0 and nothing but, because now we label the graphs outside in Excel and MATLAB. There's nothing x about the x-axis. It's y equals 0. It's the y equals 0 axis, and I convinced Keith White here. The y-axis is the x equals 0 axis. Yes, we do go beyond this to make math make more sense and to not repel students by unfriendly math of pi, of misnamed axis, of misnamed words in calculus that totally make them completely misunderstand the concept. Make math friendly again.
Thank you, Bob. Maffa?
Yes.
Would you like to?
Maffa?
No, you see? It's Maffa.
Maffa?
Dr. Associate Chairman, would you like to reply to any of that?
I would, because I think this is an important point here. And I will say, with the exception of pi, I actually agree with everything that my esteemed colleague just said. I think that there are actually places where we could improve. But progress for progress's sake is not always the best thing. Sometimes we need to pay attention that some things are not actually broken. And if it ain't broke, don't fix it. Pi is definitely not broke. And in fact, putting it into tau would increase, like I said, the number of fractions in mathematical formulae, removing fundamentality in so many places. The only real argument he has is when you're talking about the unit circle with sine and cosine. All the other places, pi appears more fundamentally than tau. And so, including tau in those places would create so many fractions, which would actually divide us rather than unify us, right? That's what tau wants to do. He wants to divide all of us into fractions.
I want to divide the circle into two halves, so 45
You
minutes.
heard what I said.
Yes, I don't want 45 minutes to be
Has he been recognized? I don't know if he gets, is it still technically my turn?
Bob, we'll give you 10 seconds to respond.
45 minutes is not 3 halves of half an hour. Why do we call it 3 pi over 2? And even
I would argue that actually it is 3 halves of half an hour.
you say that you agreed with the limits, you agree with the axes, but what about the person who was actually going to solve the Riemann hypothesis? They got to trigonometry and they said, pi over 2 is more natural than 90, and they quit math, and they were about to finish a proof of the Riemann hypothesis.
Thank you, Bob.
Survivorship.
That's what all my trick students do.
Let's get back to our questions.
Survivorship bias.
So this question will go to Dr. Palais first. In spite of your many arguable options that tau is better, there is one fact that is indisputable, and that is the cost of reprinting and re-educating everybody in terms of this new constant would be immense. Is this hurdle too big to overcome? What in your experience or opinion makes it worth it?
Go see Tau for Trigonometry, that there's some fully Tau-based trigonometry books. As Dr. Farrow's student said, they wouldn't have understood it if they didn't see Tau. We have testimonials. I will say the primary step is awareness. You don't have to get rid of Tau, but you have to know that it's wrong. You can leave Tau and just say, everything's going to look really messy.
I want everybody to realize he just said tau is wrong. Just pointing that out. I'm not sure if he's quite all there. I mean, sometimes, it's the senility kind of gets to him a little bit. Is that really who you want representing you?
Now, we're not going there.
I want to talk to the American people that make math friendlier again. It's seriously because people who don't understand math, people who dismiss math and science, cause immense harm, innumerable deaths, if you think in terms of dismissing the science in public health, if you think of dismissing the science in climate change, where since in the last 36 years, CO2 has increased more than 20%, from 347 to 417. But we repel people from math, which we need to save lives.
Thank you, Dr. Palais. Dr. Parry, Mr. Vice Chair, you've been accused by your opponent of being a climate and math denier. Would you like to respond?
First off, that's not what he said.
The fly landed on his head.
I have no idea what you're talking about. First off, he didn't say that I was a climate denier or anything like that. What he did say is that it's important that we encourage students to stick with math so that they make better decisions in society. I wholeheartedly agree with that. Your original question was about whether or not we should reprint materials if there's a good reason to make a shift. Absolutely, 100%. If there's a good reason why we should change our, the way we think about mathematics in order to improve student performance and students sticking with it, then yeah, totally we should do that. We should do it with the metric system. We should do it with a lot of things. However, tau is not one of those things. If you introduce tau, yeah, you gain a little bit of traction in a couple of areas, but you would produce so many barriers elsewhere to learning. And that would produce even worse situations than what we have with Pi. Tau definitely does not optimize what he's trying to say it does.
Thank you.
Hard to read expressions when you can see his eyebrows, right?
Gentlemen, as you're aware, the ongoing COVID-19 pandemic continues to disrupt lives in both the US and globally. Is it now really a bad time to be making massive changes to how things are done?
Do I get an answer first this time?
Go ahead, Dr. Parry.
Honestly, I think this is probably a breath of fresh air in the midst of all this stuff that's going on. It's great to finally talk about something that's maybe a little less, where the stakes are maybe a little less high, and maybe emotions aren't quite as high. I mean, my esteemed colleague is certainly a little, maybe a little too emotional and passionate about this stuff, but I'm a realist. I try to keep it, level and try to look at these kinds of things in the most unifying sort of way. And it's actually really easy to talk total bullcrap out of it. Oh wait, I should probably have said that.
See what he just
Not giving away trade
See
secrets.
what he just admitted?
But honestly, I think this is a great time to kind of get a little bit, get a little loose, have a little bit of fun, and not worry too much about all the crazy things that are happening.
Dr. Palais.
I do think that when we're modeling, when we're looking at epidemic modeling, all kinds of math, part of the goal is that trigonometry seems to be the most repulsive, in the literal sense, repelling part of math. It really takes away at our three fundamental classes of elementary functions, polynomials, the sum derivative is 0. The exponential, the derivative is a multiple of itself. Circular functions, the second derivative is a multiple of itself. And you see that by doing that a velocity twice. The velocity of the velocity is back here. There, it's just minus. So I think making trigonometry not the deterrent that it is really important, because it's what people don't know. And so the pseudo data scientists, the phony data scientists, all they can ever do is do a regression line or maybe a quadratic, and they don't recognize that there are things with cycles in them. And in fact, the most common phenomenon around equilibrium is oscillation. Our dynamical systems experts know that. So if you repel people from trigonometry because of the mess up of pi over 2 being a quarter turn, it's really harmful, and I think we lose a lot of potential people that would actually love math and end up hating it. So that's why I'm passionate.
Can I respond a little bit to that?
10 seconds.
Okay, so he talks a little bit, I need way more than 10 seconds. Yeah, he talks a little,
11 seconds.
Give him twice as much as he wants.
He talks about trigonometry
Almost
being,
twice as much.
he talks about trigonometry being the current, issue. And yeah, trigonometry is definitely a challenge for a lot of people. But if we switch to tau, some of those challenges would occur even earlier. For example, you find it in geometry where take a triangle, the sum of the angles in a triangle is pi. He would shift it to tau halves. If you look at Euclidean geometry only talks about angles as large as 180 degrees or pi radians. And any angle larger than that doesn't exist, because if you were to draw any angle here, it doesn't count on time if I'm erasing. That's not time.
Okay,
Yeah,
yeah.
there you go.
I'm sure your students agree.
Okay. Which one's the angle here? Where's the angle here? Is it on the outside or is it on the inside? What's more natural? Euclid would argue that the inside of the angle is the more natural one, which would give a natural upper limit to angles of pi radians.
No matter what gon it is, the total turn around is a full turn.
And the
It's tau.
sum of those angles is equal to the number of sides minus 2 times pi. Now, yeah, that's got a tau in it, but it also has a pi in it.
To understand it, it's just like, and then it becomes the integral case. The integral of the curvature around any curve is also 2 pi, simple closed curve. So they're universal
That's a low blow. I
principles.
actually kind of like that one.
Yeah. And then if you wanted to go to esteemed Dr. Associate Chair Parry's own field of curvature in.
Let's talk about curvature. Can I talk about curvature? Because I'd love to talk about curvature. Let's talk about curvature. Because curvature, no, because curvature is also based off of the angle sum of a triangle. If it's greater than pi, it's positively curved. If it's less than pi, it's negatively curved. If it's equal to pi, it is flat. That is a dichotomy on pi, a trichotomy on pi, not tau. It's a trichotomy on pi. And that's the most fundamental polygon there is.
He's trapped inside his triangles and polygons.
That's because they give you so much information. You're an enemy to information.
I'm on
You're
the outside.
not, yeah. Outside looking in.
I'm unbounded, you're bounded.
Okay, let's get back to the questions, the prepared questions. Thank you, both of you.
Thank you. Turning now to the election, and Dr. Palais, will start with you. Do you have any concerns about voter fraud in the upcoming election?
Considering I set up the voting mechanics.
Yes, so it has been shown that there's about a 10% effect from order of candidates on the ballot. So since pi always precedes tau, if you corrected for that, tau would have won last time too.
We didn't do it that way last time. They bought T-shirts.
Yeah, but the pies came before the tau.
Depends on which way you want to go.
And they were blue. They should-
Dr. Palais will speak about corporate donorship later.
Because we know how much money he's acquiring. Him and all of his numbers.
Dr. Parry, if you could continue to address your remarks to voter fraud.
Voter fraud. Well, I'll tell you right now, I really care a lot about voter fraud. I care about the opinion of the people, and that's why when I set up the Qualtrics survey, I clicked the box that said prevent ballot stuffing, so you can't vote twice. It's not possible. So you lock in your vote, you hit submit, it's done. So I protected the American people from any kind of voter fraud that Tal might try to do by getting his proponents to ballot stuff. And we all know that's happening. They may say it isn't, but we all know it's happening.
Where did he go get his PhD? Duke University, where Louis DeJoy has the center and the tennis player, and who stopped?
Hey, they only gave me off a little.
Who stopped the mail? Alan talked to his friends back at Duke to slow down the votes, and then to the Supreme Court to stop us from counting all those tau
Thank you, Dr.
ballots.
Palais. Thank you, Mr. Chair.
I will say that the Duke Mathematics Department actually fought the Supreme Court to prove against gerrymandering in North Carolina. John Mattingly, the chair of the math department, a friend of mine, actually did fight for that, using topology to show that gerrymandering had occurred.
Yes.
So Duke Math, go Duke, go Duke.
Go Duke.
Okay, go do. Gentlemen, we're down to our last few questions. So again, we'll give you both a chance to respond. It has been reported that Putin, the Russian president, recently came out speaking in favor of tau. Would you like to respond? Dr. Palais.
It's well
He's
known.
all about endorsements.
It's well known that the education system there has been very strong throughout, and they understand good education. In fact, it was one of my colleagues from the former Soviet Union who pointed out very easy to estimate the circumference of a circle relative to the radius by a hexagon. See if I can get a hexagon right. There's the radius, equilateral hexagon there. It's a little bit bigger than 6. What number's a little bit bigger than 6? Oh yeah, tau.
Thank you, Dr. Palais. Dr. Parry.
We talked a little bit about radius, but, first off, I don't know how much I want to be connected to Putin, but, we'll let that be, because we're not trying to be, actually, I take it back. There's a lot of great Russian mathematicians, but, and then none of this is really that political, so don't read too much of that. I will say something, though, about the radius, though. I should have brought my ball.
I should have brought my
You can't-
compass.
Right? Now, the thing is, I talked to some of my engineering friends, and their biggest beef with the radius is that you can't measure it directly. You have to first measure the diameter of an object and then cut it in half. Again, you're dividing by fractions. No, you started when you're trying to measure it, you have to measure the diameter and cut it in half. The reason why is because the diameter is a more fundamental type of object when you're okay. Again, the senility of my esteemed colleague. I mean, he's not looking too great here. Do you really want him, represent? You got to go for somebody who's got a lot of vigor. Yeah.
You turn around that many times and keep standing.
Hey, no matter how many times I turned around, you turned around twice a minute. Now,
True.
I don't know if that made sense. I was throwing anyway. Now let's talk about the diameter of an object, though. The diameter actually has a generalization to other kinds of things. You can define the diameter of any set in a metric space. You can't define the radius of one in a way that's consistent with the idea of it being the location of the center. In fact, even polygons don't have a radius unless it's regular. So, but the diameter exists for any polygon. It is the maximum, the supremum distance between 2 points on the edge. So the diameter is actually more general.
He's a supremacist.
The diameter is a more fundamental object than the radius because it has a fundamental kind of definition. So defining the circumference of a circle, defining the circle constant as the ratio between the circumference and the diameter is a more fundamental way to talk about that object.
Hear that?
Thank you both. As we wrap up, we'd like to remind the voters that Election Day is this Tuesday, November 3rd. Make sure to have your ballots postmarked by the appropriate date. One closing question, and we'll go with you first, Dr. Parry. Just short answer. Will you concede the result on Election Day, win or lose?
So I'm torn here between making a joke and saying how I really feel. Every election, the sanctity of that election is fundamentally based on people accepting the results of it. And so as such, I will accept the results of whatever the results are, whether Pi wins or Tau loses, I will accept, catch that. Whether Pi or Tau win, I will accept whatever the judgment of the people are. I just hope they vote for me.
Dr. Parry, thank you, Dr. Parry. Dr. Palais, your response.
I will finish with a quote from Arthur Benjamin's The Magic of Mathematics, a New York Times bestseller. But if you look at the formulas and applications that use pi, you will find that most of them have pi multiplied by 2. The Greek letter tau rhymes with wow. Tau rhymes with wow.
You
Has
can't
been
eat a
adopted
Tau.
to represent the quantity. Many people believe that if we could go back in time, mathematical formulas and key concepts in trigonometry would be expressed more simply using tau instead of pi. These ideas have been elegantly.
Mr. Chairman, yes or no? Will you accept the election result?
I think that's a pretty ambiguous answer, sir.
Yes, elegantly and entertainingly expressed by Bob Palais and Michael Hartle. There's no reason to worry about it because tau is obviously better.
Everyone take note, that was not a guaranteed yes. That was a very ambiguous answer.
Dr. Palais, would you like to take 2 seconds, yes or no? Will you accept the election result?
I think fuzzy math is really important.
All right.
Why are you so binary?
We're just going to have to leave it there, I suppose.
Thank you, both of the gentlemen. Thank you very much.
On behalf of my co-anchor and co-moderator, Dr. Joe Simons, I'm Skylar Simmons. Thank you all for your attendance in this debate. Again, remember, Election Day is Tuesday, November 3rd.
The polls are currently open. They can vote anytime from 4 o'clock until midnight on November 3rd.
As many times as you want.
Yeah. You heard it here. It's very first, folks.
Let's thank our debaters.
Oh. YouTube has no censorship whatsoever. We should see it here. All right, hit end stream there, Alan, I think.
Yeah.
Hi, Leah. Wow.
Type in a thank you.
I hope I didn't veer a little too much into.
I thought it was great.
You did a lot of beer.
Oh, it was fun. You guys did great.
That was amazing.
I want to watch it.
That was fantastic.
Oh, Kathy, Vivian, I